Okay, so I'm just going to go through the answers for the physics pop quiz. The first one was Janine is training for the Indigenous Summer Games in the track and field division. She runs around a track that is 2 kilometers. Last Friday, she was able to run the track 4 times in 2.5 hours. What is the speed of the jogger, or what is Janine's speed? So basically, remember that we have to do the distance over rate time, that little triangle, and we have to find the distance, the rate, and the time. Just list those down, list those along the side. Now it says here that she runs around a track that is 2 kilometers, but she ran that track 4 times. Okay, so she ran once, and that's 2 kilometers, and she did that again 4 times. So we have to times her distance that she ran by 4, and 2 kilometers times by 4, that's going to give me 8 kilometers. So our distance here is 8 kilometers. Okay, and we know that she runs this in 1.25 hours. So since we're talking about hours, we know that's in time. So that's 2.5 hours. And we are asked to find the speed, or the rate. Okay, so we're going to plug that in here. We're trying to find rate, and we have distance and time. So R is going to equal to D over T. And 8 divided by 1.5 is going to give you 6.4 kilometers per hour. Watch your units here. Since there's a kilometer there and there's an hour here, it's kilometers per hour. Now in the second question, it says, you see a lightning bolt in the sky. You hear a clap of thunder 3 seconds later. The sound travels at the speed of 330 meters per second. How far away was the lightning? Okay, so again, we have to use your D over RT, that little triangle. And I'm just going to list D, RT here on the side. So it says here 3 seconds. Okay, the seconds, okay, is time. So we're going to put 3 seconds here. And then the sound travels at the speed of 330 meters per second. Meters per second, that's a rate. So 330 meters per second. And it's asking how far away. So how far, we're talking about looking for your distance. So I need to find D, and I have R and T, so I'm going to plug in the formula D equals R times T, just like you can see here. And then R again is 330 meters per second times by time, which is 3 seconds. 330 times by 3 is going to give me 990. And you can see here there's a second in the numerator, second in the denominator, so that's going to cancel out, and I'm just left with my meters. So it is 990 meters away. This third question, Mikey shoots an arrow with a speed of 10 meters per second. What is the time required for the arrow to strike the target 250 meters away? So I'm going to just write again, D over RT. Okay, and then I'm going to write DRT over on the side here. So do I know distance? Yes, I see here there's a meter and it says 250 meters away. So that is my distance, 250 meters. Now, do I know rate? Yes, because it says here a speed, and speed is rate, and it's in meters per second. So I know that this 10 meters per second is the rate, and it's asking what time. So this here is the question mark. Okay. So let's plug in for time to figure out time. That's D over R. So time equals distance, 250 meters, over R, which is 10 meters per second. Okay? And 250 divided by 10, that's going to give me 25. And then we're working with seconds here. The meters cancel out. So then 25 seconds. Question 4. During a canoe race, Chantal paddles 406 meters in 70 seconds. What is her average speed? Alright, so again, D, R, T. Write this every single time we're working with speed and velocity questions, okay? Then I'm going to write DRT down the side. Now it says here paddles 406 meters. Even though I don't know, they say I don't know what 406 is, the fact that I see there's a measurement here of meters, I know right away that this is the distance. So it's 406, okay, in 70 seconds. Again, if I don't know what 70 is, I could see here that it's in a unit of time, like seconds or hours or days. This here is a unit of time, so I know that this 70 has to be my time. I was asking for my average speed, so this is going to be what I have to look for. So R is D over T, so R is going to equal 406 over 70, so 406 meters over 70 seconds, and I'm going to get 5.8 meters per second. Ty and Delaney are playing on opposite paintballing teams. Delaney is 1,000 meters away. With a scope, Ty goes all black ops and shoots a paintball from his gun with a speed of 720 meters per second, targeted on Delaney. How long does Delaney have to move until he gets hit? So I have here, in other words, I want you to calculate the time it requires for the bullet to strike its target. Okay, so this again is a DRT question. I'm going to put DRT on the sides. Okay, now it says here Delaney is 1,000 meters away. So we're in meters, so I know that this is a distance. Okay, and then the paintball from his gun with a speed of 720 meters per second. So I'm going to put here 720 meters per second. And it's asking how long. So that is finding out what time is. So I'm going to use T equal, going back to this chart, D divided by R. So distance is 1,000 over R, 720. 1,000 divided by 720 is going to give me 1.38. Going back to my units, I had meters here, and this is meters per second. The meters cancel out, and I'm just left with 100.38 seconds. Okay, so now we're going to get into the acceleration questions. So number 6 is Don is on a train that moves from rest to a speed of 25 meters per second in 30 seconds. What is the train's acceleration? So I'm just going to write here acceleration is equal to the final velocity minus the initial velocity all over the time it took. So if it's if the train first is at rest here, that means my velocity, it starts at, my VI starts at 0 because it's not moving, so it doesn't have a speed. So when something's not moving, the speed is just 0. So I'm going to put here VI, VF, and T here on the side. So VI, I just said, is 0 because it's not moving. And then it finally gets to a speed of 25 meters per second. And how long did it take? It took 30 seconds. Okay, so A equals VF, so that's 25 minus 0 all over 30. And that's going to be 25 over 30. And that's going to give you 0.83 meters per second. And it's acceleration, so it's meters per second squared. Question 7. Janet is driving a car traveling at a speed of 25 meters per second. And she increases her speed, so she accelerates to 30 meters per second in 10 seconds. What is her acceleration? The formula for acceleration is the final velocity minus the initial velocity all over the time it took. I'm going to write here VI, VF, and T. So she's traveling at a speed of 25 meters per second. So that's your initial, that's what you start at. And she increases her speed to 30 meters per second. So that's your VF. And she did this all in 10 seconds. So now it's just plug and chug. So 30 minus 25 over 10. 30 minus 25, that's going to give me 5 over 10. Then 5 divided by 10, that's going to give me 0.5. Now look at your units here. We're at meters per second, and since it's acceleration, it's meters per second squared. Alright, so Stephanie is driving a race car at 10 meters per second to the top of the hill. 5 seconds later, she reaches the bottom of the hill and is moving 30 meters per second. What is Stephanie's rate of acceleration? Okay, so I'm just going to write again my acceleration formula. Okay, then I'm going to write down my unknowns. Then VI, so what did she start with? Well, she starts driving up the hill at 10 meters per second. And then she, at the end, is moving at 30 meters per second. And how long does it take her to increase her speed? 5 seconds. Then plug and chug. So 30 minus 10 all over 5. 30 minus 10, that's 20 over 5. And that leaves you with 4 meters per second squared. So Janine has obtained superpowers. She's able to decelerate from 72 meters per second to 100 meters per second in 6 seconds. Oop, and I spelled seconds wrong. 6 seconds. What is her rate of deceleration? So here's a hint. It says here deceleration, and whenever it's decelerating, you should have a negative answer. So the answer should be negative. Okay, because it's slowing down. So still the formula is the same. VF minus VI all over the time. VI, VF, and T. So the initial velocity, what did she start from? So she started at 72 meters per second, and she ends up to a complete stop. She's at 0 meters per second, so that's 0 meters per second. It took her 6 seconds to decelerate, or 6 seconds to stop, so that's my time. Then plug and chug, so 0 minus 72 over how long it took, 6. Then we're at negative 72, don't forget that negative, all over 6. Now 72 divided by 6, that's going to give me 12. And negative divided by a positive is still a negative. So it's going to be 12 meters per second squared. And our last question, Robin decides to try out her new invention. At first she's flying at 50 meters per second. 5 seconds later, she's traveling at 50 meters per second. What is her acceleration? Alright, so again, write out your formulas every single time you do this. It even also helps you to memorize your formulas. And then I'm going to have VI, VF, and T. So she starts at first she is flying, so she starts at 15 meters per second. So 15 meters per second. Then later, okay, she's traveling at 50 meters per second. How long did that take her? That said 5 seconds later. So this is going to be 5 seconds. Okay, so plug and chug. So A equals 50 minus 15 all over 5. Okay, 50 minus 15, that is 35 all over 5. 35 divided by 5 is 7 meters per second squared. That's the answer.